So we're just going to go through a bunch of terms that relate to what we're going to be learning in this unit, and then we'll get into the different data types that we're going to explore today. So this unit is basically data management and statistics. So kind of like taking a sample set of something or a specific situation and learning how to represent it with different data. Okay, so let's go through a couple terms here that we need. So an attribute is, or sorry, a variable is an attribute that can be measured. One variable data is a set of data that describes one attribute per item. So one thing that can be measured per item in a sample. Okay, and then two variable data, a set of data that measures, gives measures of two attributes for each item in a sample, or sorry, in a graph, we can say. Scatterplot is a sample of data that represents a series of points. And it looks like this. In order to do a scatter plot, you need two variable data. So you need to have like something, for instance, like this, which is like height and weight or mass or something like that, so that you can plot the two data points together. All right, dependent variable, this value changes according to the independent variable. And independent variable, this value determines the value of the dependent variable. So if you remember from some of our previous units, I always asked you like, oh, does time depend on the speed or does speed depend on what time it is? And then kind of thinking about it that way. Okay, correlation is the strength of the linear relationship between two variables. So does it look like it kind of forms a line or does it not? If the points are like really far apart, then that probably is a weak correlation versus a strong correlation. Cause and effect relationship, a relationship between two variables where one variable causes a change in the other one. Line of best fit, a line that passes as close as possible to the set of plotted points. Okay, and then outlier, an observed value that differs markedly from the pattern established by most data in the set. Okay, and then linear correlation, a trend where points may lie in the general direction of a line. And then correlation coefficient. This is a measure between -1 and 1 of how closely data can be described by a certain type of function, so linear, quadratic, exponential. Do you remember in Desmos when we were plugging in values and then looking at the regressions and looking at that R value? And the closer it was to 1, the better the correlation for that specific type of graph, like linear, quadratic, or exponential. That's basically what we're looking at here. All right. Also, if it's close to -1, that indicates a close fit to the data as well. We're going to actually add, so you can flip back. We're going to add 3 more things because some of the things actually come up in this lesson, which is mean, median, and mode. Do you know what any of these are? Do you remember back from grade 9?
I don't know.
Vaguely. Okay. The mean is essentially the average of a data set. Or say like of a set of values. Okay, so you basically add all values and divide by the number of things that you added. Okay, so if you had 5 tests and you wanted to find the average of all of them, you would add all of their percentages and then divide them by 5 because that's how many tests you were adding the percentages of together. All right, the median is essentially the middle of a set of data or values. So it literally separates the higher half of the data from the lower half of the data. Okay, so if you had, let's say, 21 values, you would find the center of those 21 values, like you'd literally organize them in ascending order, all the lower numbers all the way up to the higher numbers, and then you'd find the middle number in between those. If it's an even number of data, you'll take the 2 numbers in the center, like let's say there's not just like a middle one, and there's 2 that are in the middle, you'll add them together and divide by 2 to find a median. Okay, and then the mode is the most frequently occurring number in the set of data. Okay, perfect. So let's get into the first lesson. So we're just going to look at what we call 1 variable data and 2 variable data and different ways to express those, and then different ways to read the data sets. So here we have a bunch of information in a table. It is about the Canadian women's university hockey team that scores points in the 2006 and 2007 season. We have all the names of the players, the number of games they played, their goals, their assists, their points, and their penalties. So here are 2 types of graphs that we took from that set of data. So for the questions below, you're going to decide which graph we should look at here, or you can obviously look at the table as well. But some of the graphs might be the easier way to read them, and then decide from there what the answer should be. So which player had the greatest number of penalty minutes? So which of the 2 graphs above is going to help you with that, the bar graph or the scatter plot? Okay, so then which player had the greatest number of penalty minutes? What can you see? Yep, perfect. So we can see Davis has the highest bar of over 50 minutes, so probably like 53 or 52 minutes. Actually, we can even see it on the chart here, 54 minutes. How many players experienced more than 20 penalty minutes in the season? So if we look at our bar graph, how many of the bars are going above 20? 6, yeah. This one doesn't count because it just reaches 20. This one says more than 20. So that would be all of these first 6 that go above the 20 line there. Okay, so 6 players. Is there a correlation between penalty minutes accrued and goals scored? Goals scored. Oh my goodness. Goals scored. Okay, so which graph are we looking at? Which one compares penalty minutes to goals scored? Scatter plot. Okay, do you see any kind of correlation with the points? Like, is there a line that's being formed? Is there a quadratic? Is it just random? Yeah, so it's pretty inconsistent then, right? Okay, so there's no correlation that can be observed. Like it's not going up in a linear fashion because we have points over here. It's not really forming like something that looks like a quadratic and not really exponential either. So we'll say no correlation. Okay, and then this one says which graph displays two variable data. So if we look back at our definitions here, two variable data is a set of data that gives measures of two attributes. So two values that can be measured specifically for each part of the graph. So would that be the bar graph where we have the names versus the penalty minutes, or would that be the scatter plot where we have penalty minutes and number of goals scored? Scatter plot. Perfect. Okay, it has goals scored as a measurable attribute, and then it has number of penalty minutes. That creates two variables. Okay, so I'm going to give you some examples of one variable data or like how we can display one variable data and two variable data. And I'll show you some examples of what they would look like online. So a tally chart is basically just if you were to create various things that you're tallying, like if you bought a bag of M&Ms or something like that and you were tallying reds, blues, greens, and you basically just have like red and then you have your tally going, right? And then blue and you've tallied 3 of them or whatever. That's a tally chart. It's just a way of obviously tracking how many of something that you have. We also have bar graphs. So this one I didn't pull up an example of because there's an example above. This is an example of a bar graph. So you would have something specific like it could be the name of a person or the name of a city, something that's not really like a numerical measurement typically. And then you would have some kind of numerical measurement that you're tracking for that. And then there's histograms. So these are very similar. I'm going to show you the difference between the two here. So here we have a bar graph and a histogram. So the difference between a bar graph and a histogram is that a bar graph is just going to give you specific categories, whereas a histogram is going to give you a specific number range, and this number range needs to be like a continuous number range. So this one is saying like from the years from like, let's say 1960 to 1965, I'm guessing is what it means by years. Then you're tracking what the GDP is of a particular country as a percentage or whatever this is trying to say that we're tracking. So it's literally giving us a range of years down here, and then you're tracking the overall percentage. And then from 1965 to 1970, and you'd have a range of years that you're filling in a bar for. Whereas these ones are just like individual categories. Okay. All right, so that's bar graph versus histogram. Very similar. We have frequency tables. So frequency is essentially like the amount of time that something would come up. So if I gave you a number set, like 2, 3, 1, 2, and so on, this is your number set. If you put in, so this is like the number of goals in recent games. So 2 goals, 3 goals, 1 goal, 2 goal. Then it's saying how many times do these scores come up in the list of data. So how many times does 1 come up? And then we would count 1, 2, and we would write the frequency as 2. So in 2 games, they scored 1 goal. And then in how many games did they score 2 goals? Well, they scored 2 goals in 5 games based on the set of data, right? So just like number of times something has occurred. Okay, so that's a frequency table. We have pictographs as well. So pictographs are pretty good for more like elementary school type stuff, but you might see something like this where you have a particular picture that represents the number of votes for, let's say you were tallying favorite fruits of people. And grapes are obviously the least favorable because they got 2 votes, but you're showing that with pictures. Okay, and then a circle graph is essentially like a pie chart. So you would have something that shows like the variety of percentages in kind of like shown out in a circle to represent slices of how big certain things are. So far, so good? Okay, that's for one variable data. You can also analyze one variable data using mean, median, or mode, but there's not too much else that you can do with that other than just like analyzing the actual data itself and saying like, oh, if I'm looking at a pie chart, then 20% of people, their favorite movie out of the people that were tallied was a sci-fi type of movie, right? Obviously, you can take that information from there as well. Otherwise, mean, median, mode. 2 variable data can be things like ordered pairs. So if I give you like a bunch of XY coordinates for something, it can be scatter plot as we saw above, and it can be 2-column table of values. So time and height or something like that, or time and distance could work for that. Okay, so you're going to tell me which of the things below is 1 variable or 2 variable data. So NOAA researches annual hours of sunshine in Canadian cities. Are there 2 variables or 1 variable? So they have to be measurable values, right? Like, right. So this one would essentially, you could like almost do it with a bar graph, right? You could say like Toronto, Calgary, and so on. So the annual hours is the variable there. So this is going to be 1 variable data. Okay, a study compared the length of time children spend playing video games and the time they spend reading. Is this 2 variables or 1 variable? Yes. Length of time playing video games and time they spend reading. 2 different variables. Perfect. Okay, so let's talk about what types of ways we can represent data that's shown here. So we have some data below. It says for a class project, Dylan surveyed students about their part-time jobs. So he has hours during the week and hours on the weekend, and then he has all the student names over here. So if he's just showing how many hours each student worked on the weekend, what type of graph would be best for that? And is it 1 variable data or is it 2? To show just hours worked on the weekend with the student. Okay, that would be 1 variable data because hours worked on the weekend is just your 1 variable that can be measured and is changing for each student. Okay, and what would you suggest, maybe out of the list that we went over up here, might be a good option for how we could show that in a chart? Yeah, bar graph is probably a good option. You can have each student name on the bottom, and then you can have their number of hours worked and just do like a bar going up to each of the hours. Okay, perfect. We're going to do that on the next page. So bar graph is the best choice because we can label student names. Then draw the bar up to the number of hours worked. And that will individually show how many hours each person worked. Okay, and then what type of graph would best show a possible relationship between weekday and weekend hours? So weekday hours worked and weekend hours worked. Is that two variables or one variable? Two variables. Okay, so with that we could write them as ordered pairs. Well, actually, we just have a graph. So it says what type of graph. So the only option here is like you have table of values and ordered pairs, which are not graphs. And then we have the scatter plot option. So that's going to be our only option for that one. Okay, so we're going to use a scatter plot. And we're going to say scatter plot is best for two variable data like this. Okay, and then we're going to actually make the graphs. So the first one that we'll do is the bar graph. So we're going to do student name on the bottom, and then we'll do number of hours worked on the weekend going up to the top here. So let's draw out some lines here. And we're always going to be doing labels here as well. So we'll have the student name, and then we're going to say maybe time worked on the weekend in hours. So wherever possible, you're always going to put the unit of measurement from there. Obviously, for student name, there's no unit of measurement. It's just a name. Okay, so let's start by copying out each of the names here onto the bottom. If you want, I have an extra copy of this that you could just, so you don't have to flip back and forth. Okay, so let's write them out. And what we're going to do when we do this is keep it consistent in like one of the areas here, and maybe we'll do every other thing so we have each area as like a separate part where we can create a bar graph from there. So we'll have Adel, Anya, Ellen, Aaron. Glad all these names are short. Layla, Mason, and Petra. And then we're going to have to create some kind of scale that we use over here for number of hours worked on the weekend. So we can see from the data set, if we look back here, we go anywhere from 6 hours all the way up to 18 hours. So if we were to kind of plot this over here, what do you think would be a good scale for us to do? So that's going to give us like 5, 10, 15, 20, and that's going to be all right in here. I think we could probably spread it out a little bit more than that. Maybe like by twos. 2, 4, 6, 8, 10, 12, and so on. And then at least we have like a good spread where we can actually read it and see. All right, so Adil, or however you say that name, Adil, works 18 hours. So we're going to put that bar all the way up to 18 hours, color in the rest. Anya works 12.5 hours. So we should have that bar about like a quarter of the way up in that section, because half the way up is 13. Ellen works 12. Fiona, it's 8. Aaron, 16.5. About like a quarter of the way up in that box. Layla, 16. Mason, 8. Okay, and then Petra, 6. All right, and then we're going to do the scatter plot as well. So with our scatter plot, we need, doesn't really matter, one of these is not necessarily dependent on another. So it doesn't really matter which ones we use as X and which one we use as Y. However, it might be good because we have during the week first in this table, and then on the weekend separate. Maybe we do during the week as our like X, and then on the weekend maybe as our Y, and then we'll see if there's any correlation between the two. All right, so I just actually snip this over here quickly. You can start making your X and Y axis. So it'll be slightly different, right? Because you're not going to have the names of the students anymore. So we'll have, I'm just going to move this down ever so slightly. All right, so we're going to have, let's say, hours worked during the week. And obviously it's kind of implied that the unit of measurement is hours, but we can put hours in bracket as well. And then we will have hours worked on the weekend. Let me see if we can go by ones here. 1, 2, 3, 4, 5, 6, 8, 9. Yeah, that looks good. So I'm gonna actually go by ones this time because it'll be nice and spaced out. And then we need to get up to at least 17 for hours worked in the week. So I'm going to go by ones on the bottom here as well. So I'm just going to skip every other one. We'll do like 2, 4, but obviously this is going to be like 1, 2, 3, 4. I'm just going to label every other one, but I am going up by a scale of ones. Okay, and then same thing on the y-axis. I'm going to go by ones, but I'm going to label every other one. And we just made it right at the top here. That's good. Oh, you started a little higher than me. You're going to have to like extend your graph a little because we have to get up to 18 for the first point. Okay, and then of course this is 0, right? Okay, so for the first student, they worked 0 hours during the week and 18 hours on the weekend. So we're going to put a point at 0, 18. And then they worked 5 hours during the week and 12.5 on the weekend. So 5 and 12.5. And then 8 and 12 for the next student. 17 and 8. So 17 and 8. Then we have a point at 0, 16.5. So that'll be halfway between these two boxes here. So yours is off your graph a tiny bit. And then 10, 16. Nine 9.5 and 8. And 15 and 6. All right. Do you see any kind of correlation here? Is there any function that you can recognize that these points are kind of like making? Like, is there a line or? But is there any consistency between like all of the data together? Okay, so there's basically just like a weak correlation that maybe some people that work more hours during the week work less on the weekend, but it's relatively weak. So we'll say weak correlation in this data. Doesn't necessarily mean if they work more during the week that they'll work less, although the trend kind of is going a little bit downward. But again, we'd want those points to be a little closer together to be a stronger correlation. Okay, good.